Assalamu alaikum. Now I am going to show you a substation. I am in a substation of 132 kV to 33 kV step down substation. Here the primary source voltage is 132 kV and the secondary voltage 33 kV. It is going to the distribution authority. Here these are the 132 kV switch yard, and these two are the power transformer, step down power transformer. There are two type of bushing of the transformer. The long bushing height long height bushing, it is the 132 kV, and the short bushing, it is a 33 kV side bushing. And this is the 33 kV switch yard. Output of the two transformer came to this substation, and there are so many, I think 15 to 16 33 kV distribution feeders are here. Conductor came this insulator, and from insulator there is a drop conductor to this city. First one is PT, this one is PT, potential transformer of 33 kV, and after that this is the current transformer, 33 kV current transformer to 2500 ampere current transformer. From current transformer to circuit breaker, this one the 33 kV circuit breaker of 2500 ampere circuit breaker. From circuit breaker there is a isolator or disconnector, 33 kV disconnector. From disconnector it is going directly to 33 kV bus. This is on the bus. And all these are the outgoing feeder. This is on the distribution station auxiliary transformer. This is a station auxiliary transformer. Okay. It is not connected yet because the whole substation commissioning is not finished still now. I think within some time it will commissioned. The long bushing, this is on the 33 kV side, and this is on the short bushing. This is a 440 or 400 volt bushing. What is the rating of this transformer? Okay, we can see no nameplate are here. Okay, this one the nameplate. अरे Okay. What is the nameplate of the circuit breaker? This is on the nameplate of circuit breaker. Voltage, rated voltage, system voltage 33 kV. Rated maximum voltage 36 kV. Current, rated current 2000 ampere. Breaking current 31.5 kiloampere RMS. Short time capacity 31.5 kiloampere for 3 seconds. And making current 80 kiloampere peak. Power frequency with distant voltage 70 kV RMS for 1 minute. Impulse with distant voltage 170 kV peak to peak. Our operating sequence: open, then 0.3 second, then close, open, then wait 3 minutes, then again close, open. Closing coil voltage 110 voltage DC and opening coil voltage 110 voltage DC. Okay, this circuit breaker made by Energy Pack, Bangladesh. Okay, this one is isolator 33 kV with the rating mechanism. It is handle operated, no motor operating mechanism is here. Rated voltage 33 kV, rated current 1250 ampere, impulse voltage 170 kV. Okay, etc. No problem. We have to see another items. Now I am going to 132 kV side. This is on the power transformer. There are two power transformer. Is a rating of 132 kV to 33 kV voltage rating, and the rated capacity is base load 80 MVA, and with cooling or force cooling it is 120 MVA. This transformer is made by Energy Pack, Bangladesh. Type of cooling: oil natural, air natural, and oil natural air force. 80 MVA is based on oil natural air natural, and 120 is oil natural air force. Rated voltage 132 kV high side, low side 34.5. Rated current HV side 349.9 at 80 MVA and 524.854 at 120 MVA. Low side current 1338.78 ampere at 80 MVA and 2008.17 at 120 MVA. This is a vector group DYN1. 3-phase, percentage of impedance, step 1 13 point something, Step 2, it is not visible. I think it is 12 point something, and last step at 21, it is 11.7 and something. Okay. There are 21 tab. This is on the middle tab. 11 A, B, C. 11 is the middle tab. Normally, the regular practice in a power transformer, there has 17 tab. 17 tab. And 9A, 9B and 9C are the middle tab or nominal tab. That side is high side of the transformer, the high side bushing. Earlier bushing there is a lighting arrestor. Either any switching impulse from the circuit breaker switching or thundering. Every time a type of impulse will arrest by this lighting arrestor. There is also a arrestor at secondary 33 kV side. There is a current transformer. It is used to measure the current. In a nameplate, it is shown that primary side current, maximum current 500 up to 500 ampere, but it is not possible to measure directly 500 ampere. So this CT convert to 500 ampere to either 1 ampere or 1 ampere. We know that all the measuring equipment are can measure either 1 ampere at full scale or 5 ampere or at full scale. The earlier days there was practice of using 5 ampere measuring equipments, but nowadays all the measuring equipments are based on 1 ampere at full range system. And this one the circuit breaker 132 kV2. No 2. It is fixed 132 kV circuit breaker. The maximum rating is 145 kV. Okay, let's see the nameplate. This is the operating mechanism. The top connection, it is called the upper terminal, and the middle connection, it is called the lower terminal. The upper terminal, it is the source side. All time our voltage here, and the lower terminal, when the breaker is closed, there is voltage here. Upper terminal and lower terminal, it is connected. When disconnected, there are the voltage at upper terminal, but no voltage at lower terminal. There is a contact between this terminal inside the porcelain insulator. Okay, let's see the circuit breaker. This circuit breaker mechanism, it is made by GE T&D India Limited. Okay, this is the spring charge indication. When the spring charge mentioned here, this direction is spring charge. If the spring discharge, this indication will come to here, indicate here. It will rotate this way, and this is the indication of on off. The circuit breaker is now closed, so it is showing on. When the circuit breaker became open, it will show, indicator will rotate to this direction. There is a rating SF6 circuit breaker type GL312F1/4031P. Okay. Rated voltage, nominal current. Rated voltage 145 kV. It is mentioned here that all the 132 kV system are maximum rated to 145 kV. It is applicable for both circuit breaker, current transformer, every equipment of 132 kV sides. And for 230 kV system, it is the maximum rated to 245 kV. Okay, let's see another rating. Ampere. Rated ampere is 3150 ampere. Frequency 50 kV, RMS kV. Power frequency with stun voltage, lighting impulse with stun. Okay, power frequency with stun voltage 275 kV, and lighting impulse voltage 650 kV. Fast pole to clear factor. 1.3. Short circuit current, short time withstand current. Okay, short time withstand current 40 kiloampere. And short circuit breaking current. Which one? Symmetrical and asymmetrical. Short circuit breaking current symmetrical 40 kiloampere, is asymmetrical 46.8 kiloampere. Out of phase breaking current 10 kiloampere. Line charging breaking current 50 ampere. Okay, this is the operating sequence. Open to wait for 0.3 second, then close and open again, and then wait for 3 minutes, then close and open again. MPa, absolutely. This is the SF6. They are SF6 gas pressure. Guys, we know that in this circuit breaker, the insulation between the two contacts when the breaker normally keeps open, maintained by SF6 gas. Insulation between two contract at open condition maintained by SF6 gas. This gas pressure is given here 0.7 MPa megapascal absolute. Amount of gas, SF6 gas, total mass of SF6 gas, it is approximately 10 kg. Total weight of the circuit breaker 1534 kg. This is IEC standard 62271-100. Manufacturing date year 2021. Okay. This is first one, left one is red phase, middle one is yellow phase, that is L2, and right one is blue phase, that is L3. This one the SF6 gas density meter. SF6 gas density meter. Below 51.1 it is red zone. In this zone it is strictly prohibited to operate the circuit breaker, either per or load or no load, any condition. 51 to 54, this is on the alarm condition, that showing that we have to check the gas pressure and fill again, if because it is the before or earlier of danger condition. 0.54 to 0.64 megapascal, it is the healthy zone, green zone, no problem. And above Also above 0.64 it is also green zone, no problem. Guys, here it is visible that at yellow zone there are two mark also. First one the from 0.54 to then the first indicating point and second indicating point. The first indicating point there is the first alarm, and after that there is second alarm. Two type of alarm are in here. Alarm contract are here. For the first indication there will be a alarm to the control room, and for second marking there will be also another alarm. Okay, then let's show another item. This is the firewall. It is recommended to place in between any two of the transformer, because in any circumstances if there hazard or any electrical accident, there may be fire caught on the transformer, and it is mentioned that if there any fire happen to transformer and the transformer will come out, it is very dangerous, and very rapid time the fire can caught to other equipments. The purpose of this guide wall is to prevent the second transformer from the fire. This is on the bus 132 kV bus. It is mentioned here that the circuit breaker also operate in both load and loaded, any condition, no problem. Faulty condition as well as healthy condition. This one isolator, it is also switching device, but isolator can only operate at no load condition. What will happen if we operate the circuit isolator at load condition? No doubt that within some millisecond all the finger or contact point will be burned. But why this happens? Inside circuit breaker there are SF6 gas that keep the circuit breaker, keep the two contacts insulated when open condition, and during the opening condition there are some electric arc in between two contact, but this SF6 gas break this continuation of the arc. SF6 gas act as insulating material and cut or discontinue or interrupt the continuation of the electric arc. As a result, within some time the electric arc or current flowing through the contact permanently interrupted. But there is no gas, insulating gas for isolator, because it is outdoor. There is no way to keep this contact in a closed vessel, and so isolator is used only for closing or opening any load or any feeder at no load condition only. This isolator is at now open condition. This one the female contract, and this one this one male contract. Okay, now this one is, this isolator is at closed condition. Both male and female contract are closed in state. Current flowing from one contract to another contract. Voltage level at both contract are the same, 132 kV. But what is the status of this open isolator? Here also voltage at both condition, because one side is connected with this another isolator, so voltage is here. The other end is connected with bus. Bus is charged, so there is voltage also here. But the issue is that from this bus current is not going to the feeder. Current is going to this bus, because this isolator is closed and power is taking from this bus. Here and okay, let's see the other equipments. These are the substation earthing, secondary structure earthing. This is a ground conductor. It is connected through mesh with the gantry structure. This is on the lug, cable lug. This is a copper conductor, but insulated with PVC lug, and is connected with the structure. This is also another earthing. It is connected with the operating mechanism of isolator. Operating mechanism of isolator. Operating mechanism of isolator rating, motor drive operating mechanism, is not so very much important. So this is one another isolator. This isolator also at open state, open condition. And this is one another circuit breaker. This is the stair. This is the stair. Stair is used to work on the circuit breaker mechanism. If there are any problems or trouble, the technician need to work the mechanism. But the height of the mechanism, operating mechanism, is approximately up to 7-8 feet. So normal it is not possible for human to work that place. So stair is required. These are the gantry structure. Gantry structure leg. gantry structure leg. There are 4 nut and bolts. These are anchor bolt. These are nut. One can ask how to climb this gantry tower if required to maintenance of the above bus. There are step bolt. Here. There are many step bolts. By using these step bolts, the linemen climb to the gantry tower. It is mentioned that every equipment of high voltage substation must be connected to ground to avoid any electric shock for maintenance purpose. Not only maintenance purpose, for also safety of the equipments, ground is mandatory at grounding point. These are grounding. It is connected through this gantry structure to earthing mesh below this surface. These one are another set of cities. The first one, the circuit breaker line. There are 2 circuit breaker and 6 poles. These are cities. 1, 2, 3, 4, 5, 6, 7, 8, 9 cities. All are current transformer. After that, there is another set of isolators. Each isolator have 3 poles RYB. It is mentioned here that every equipment in substation have 3 conductor or 3 connections that are called RYB, or either RST, or either ABC, or either L1, L2, L3. After isolator, there is a potential CVT, capacitive voltage transformer, set of capacitive voltage transformer. There are also 3 capacitive voltage transformer. What are inside a capacitive voltage transformer? Normally, the construction of a potential transformer. What is the function of potential transformer? Potential transformer step down the system voltage to 110 volt. It is either be 132 kV or 230 kV or 400 kV, no problem. But the output of all CVT are 110 volt. Then the question is how to step down this voltage 132 kV to 110 volt. Simply for PT, it is simply a primary to secondary step down transformer. The voltage ratio of the primary side of the transformer is 132 kV and the secondary side is 110 volt. It is a system voltage, but for each phase the primary side ratio is 132 kV divided by root 3. It is approximately 76 kV, and the secondary side side is 110 divided by root 3. because normally the system voltage is 132 kV, but for phase voltage of each phase it is 76, approximately 75 to 76 kV. But the question is, how to CBT work? CBT work in different way. The fundamental construction is same. Primary to secondary, there is transformer of primary to secondary, it step down the voltage. But for PT, there is only a simply transformer, 76 kV to 65 volt, 76 kV to 65 volt turn ratio. But for CBT, normally there are two transformer, two stack of transformer in series. The first stack maximum voltage drop there, but the nearest with ground stack there are approximately 11 kV to 15 kV voltage drop. This drop is taken to a small transformer. The ratio of this transformer is 11 kV to 65 volt. These are the difference. The nameplate of the CBT is out of my limit to show you. No nameplate are there, but it is out of my limit. The nameplate is here. Nameplate is here, but I think it is not clear visible. The last or the first, the last or the first, when the power enter any substation, these are the first of substation for incoming feeder, but for outgoing feeder these are the last point of substation. And this one the lighting arrestor. Any thundering stroke can arrest by the conductor also, though there is a earth wire above the conductor to through all the line. The upper connection, the upper two connection is earthing wire, lower three connection they are the phase conductor. The upper two wire are earth wire. There are those two circuit, so above of each circuit there is earth conductor, so that if any lightning strike come down from the sky, the earth wire above the phase conductor will arrest this lightning strike, and it will neutralize by sending to ground. If any case this earth wire fail to arrest the lightning stroke, there are possibilities to enter this lightning strike to substation equipment, could cause damage the equipments. The function of the lighting arrestor is to arrest any type of lightning strike in conductors if there exist. What is the rating of this lighting arrestor? Normally, knowing that, we have to learn what is the phase voltage of this 132 kV system. It is approximately 74 to 75 kV. The rating of the lighting arrestor are calculated so that it is approximately 50 to 60% more than the system voltage. So it is 120 kV, 120 kV system connected with 74 to 76 kV system. This one is a new substation. It is commissioned 2 days ago. Technicians are working on cross arm to the transmission towers. There was a existing new transmission line, but a LILO work is continue here. What is LILO? LILO is nothing. Just assume there is a existing transmission line or 3-phase conductor. If we cut the 3 conductor, there will be 6 terminal. These 6 terminal are coming in this substation. There are linemen working on the transmission line cross arm. I think they are connecting the jumper to dead end connector. They made a suspension bed there for jointing the conductor and jumpers. That is compressing the different type of connectors. The compression machine is there. They pull the compressing machine from ground to this bed and compressing their different type of conductors with compressed connector. This is the search counter. What is the function of search counter? This search counter is showing the leakage current, and this is a search counter. If the search register arrests any strike, lighting strike, this counter will count the number of strike. One. Okay. Okay. How the lightning arrestor is work? Lightning arrestor work as a non-linear resistance. At normal system voltage, the lightning arrestor show high impedance, but at a certain voltage above the system voltage, the lighting arrestor show short circuit behavior. That is, at normal voltage or below the critical voltage, it works as a high impedance or open circuit, but after crossing crossing the critical voltage, the same lighting arrestor acts as a short circuit condition. It is the non-linear properties of earthing resistor, lightning arrestor. At normal condition, there are some leakage current flowing through lighting arrestor. This leakage current is shown by this leakage ammeter. It is ammeter, but now this circuit is at open condition. There is no voltage here, so no current showing. Normally the range of this current are 0 to 0.5 milliampere. And how the counter work? At every surge strike or at every time the surge arrestor or lighting arrestor work as a conductive path or work as a lighting arrestor to arrest the lightning stroke, the number of this counter increase at every time. Then how we will identify that? There are some operation happen by the lighting arrestor. For this purpose, anyone need to take record this lighting arrestor. Suppose it is now 11. If after 1 month this number increased to 12, then we will be confirmed that lightning stroke happened in this conductor, and the lighting arrestor arrest this conductor or neutralized arrest this voltage or neutralized the lightning stroke, and the number of this counter increase from 11 to 12. Normally there is a solenoid. There is a solenoid. When the lightning stroke hit the conductor, this time the lightning arrestor act as short circuit condition, and this voltage flow through lightning arrestor to ground. This time the solenoid, this is the solenoid act and hit a mechanical counter, and the number of counter increased at its operation. This is the OPGW, optical fiber ground wire. Actually earlier the days only earth wire are used above the conductor of the conductor at towers, but nowadays one earth wire is directly earth wire, and second earth wire is not just earth wire. Instead earth wire, OPGW is used, optical fiber ground wire. Optical fiber is used for communicating purpose, and the ground wire act as the same function of the earth wire. Then how optical fiber are inside a OPGW? Normally these are the OPGW conductor's strand. There is a hollow strand inside this strand, and optical fiber are inside this hollow strand. It may be either 12 core, sometimes 12 core of optical fiber, sometimes 24 core optical fibers, sometimes 48 core of optical fiber are keep in this OPGW earth wire. Here is the optical fiber connecting point box, optical fiber connecting box. This OPGW is last point of this OPGW is terminating at this box, and there are some jointing inside the box, and another connection is going here to directly control room. Okay guys, today here the ends showing the different type of substation equipments. Future I will show you more about the substation equipments. If possible, please pray for me, and if you like my video, please subscribe my channel to influence for making new videos. Thank you. Assalamu alaikum.